Hey everybody, I'm Sam Madden. I'm very pleased to have Ty Brady here from Amazon Robotics. So,
thanks, Sam.
We're just going to kind of learn a little bit about how AI and generative AI in particular is affecting the robotics industry. So let's just maybe Ty, you want to say a little bit about your background?
First of all, it's just great to be back on campus here. I'm a graduate. I spent about a decade here in the 90s. I was here when the internet came to be a thing here in the 90s. Started programming in the 70s, personal computers in the 80s, here at MIT in the 90s. Done a fair amount of automation and robotics. What I do, my title is that I'm the chief technologist for robotics at Amazon. We have the world's largest fleet of industrial mobile robots out there in the world. Very applied, very practical is what we do. We really believe in a collaborative philosophy of people and machines working together. And the age of physical AI is here. We have grown quite considerably over the last decade. We ship billions and billions of packages every year, billions. About 75% of every package that's delivered actually goes through one of our robotic systems. We're really proud to be here in the greater Boston area. Our world headquarters here are here in the greater Boston area. And what a time to be in robotics, for sure.
Awesome, cool. Well, I'm excited to hear more about it. So, I think maybe we'll start off by just talking about what's the state of robotics today, and then we can, kind of transition into.
Yeah, I brought a little home video,
things.
if you like, just to set some context, really about this application of physical AI systems, right? So it's kind of the mind and the body coming together. We've had robotic systems for a while, but it's really a new era where we can bring AI, machine learning, generative AI. To our robotic system. So I have a video kind of just showing really the practical side of what we do with our robotics and kind of how you get your deliveries you're doing. Awesome. You caught in the beginning. Thanks. I'm really proud of that. Thank you. Amazing team that we have here. A lot of MIT graduates, a lot of folks in the greater Boston area. I'll tell you, I don't know if you caught it in the beginning, the manufacturing of those drive units in particular, we do all of the manufacturing actually for those drive units right here in Massachusetts. Like I said, we've manufactured more than 1 million drive units here in the Bay State. We have about 18,000 employees that we employ in Amazon inside of Massachusetts. We put about $18 billion into the economy. So I'm using those stats just to show you that this practical side, the very applied side of AI and robotics, when you are solving problems that people need, it really kind of advances the state of the art.
Yeah. I mean, what I thought was really cool about it, he's got these arms, which you sort of think of industrial robotics being arms that move stuff around, but then you had these little, I guess you call them drive units, that are sort of scooting around on the floor with people there. Can you talk a little bit about how constrained the environment that these things are? They making autonomous decisions, or are they following fixed paths that are pre-planned? I mean, can you talk a little bit about what's happening?
It's a great observation. We've been, first of all, the philosophy that we believe, again, as we put people at the center of the robotics universe, is a collaborative environment. So we want people and machines. We want to augment and amplify human potential through our machines. That's our core philosophy. And to do that, we do technology development with project context, right? I mean, that's the best way anything is going to get done. You need a real problem, what problem you're trying to solve, in order to focus the technology to work at a high reliability. And when you ship billions of packages, even if it's just a billion, remember that 1% is 10 million. I can't have 10 million defects out there that we're going to have to go chase down. So what we're doing is we're actually achieving, I'd say, a world-class capability in mobility, in manipulation, in identification, in storage, in sortation, in pack. Just real core fundamentals when it comes to robotic systems. And our generative AI systems, our machine learning systems, our AI systems that we have really brought kind of the where we had the body before, we kind of have the mind and the body now coming together at a really accelerated pace in the last 3 years. Let me just talk a little bit about the manipulation space. So, like I said, I was a young Jedi in the 70s and the 80s, and I really enjoyed computers. I really enjoyed programming. And the state of robotics was very fixed. It was really, in the manipulation space, it was maybe for welding for the automotive industry. Very fixed, precise patterns of what it needs to do, and if there's any irregularities, forget about it. It's out. And we've come a long way over, I'd say, a number of decades here, where we're much more adaptive, much more modular in our approach of how we're doing robotics, right? So, for example, the drive units that you saw there, we started with the fabric pods. Again, I'm missing the basics here. What we do is we're a goods-to-person fulfillment strategy, right? So what we used to have inside of Amazon is a person would have a cart. Good to see you, Dan. We'd have a cart, and you would walk for a long distance, grab the item, put it into a cart, go to another aisle, grab the item, put it into a cart, and then come back, pack the item out, and off goes the order. And Amazon did that for a number of years. Actually, Jeff Wilkie, who's a graduate from the Sloan School here, really brought these lean principles to mind and started to optimize that process. Well, around 2010, Jeff saw this kind of remarkable new idea, which was a goods-to-person type of fulfillment center, fulfillment process path. And instead of a person going to the goods can come to the person. Okay, and that was a really giant deal because not only was it better for our employees because they didn't have to walk so far or remember everything that they needed to pick, but it was much more efficient in terms of time, but also in storage. So because if you didn't need those human aisleways, and you can kind of pack things like the advanced library does, or pack them in like when you go to Fenway Park, all the cars there, I could pack about 40% more goods in that same footprint. Okay. So robotics has really enabled this revolution where I can have many more goods in the same footprint and also increase the efficiencies while making it safer for our employees. So that worked. So that was about a decade ago. We started in what we call a structured field approach. So a structured field means that there's fences around the robots, right? And we're moving those goods at will to pick stations that in the interface of people and machines is kind of at these stations that we design and build. And that is actually very efficient and has really changed the game for Amazon. Like, for example, in terms of productivity, over a decade, we've hired hundreds of thousands of people, right? We've created hundreds, literally hundreds of new job types because of robotics. So we gain this productivity. But also, I don't know if you saw in the video, we have these little green robots, and what that signifies, we actually wanted a different color, very intentional, because they are collaborative robots. They don't use fiducials, they're not behind fences, they're safety certified, and they can move goods at will. Yeah. Again, just the very basics, moving things at will around people in a safe manner. We rolled out a few years ago, about 3-4 years ago, and we're using that at our inbound and outbound docks. A very practical application of just, I got a stack of stuff over here, and I need to get to the right truck, right? And we've had robotic systems and AI systems that actually help sort those goods, but just move it from here to there. But there's a trick. I need you to move it around people. And I need for people to understand what they're doing. I need the machines to understand what people are doing so that we can better collaborate and work together. That is working.
One question about that. I was sort of thinking as these robots are, like, this is an incredible planning problem. This, like, the logistics of there's billions of packages coming in and then billions of packages that have to go out every day. Like, is this a centralized planning system, or is it like are the individual robots like autonomously going and figuring out what package they should move now, or how does it all get coordinated?
It's a little bit of both. First of all, there's beauty in billions. There's beauty in billions. Right, because if you're achieving the billions of whatever operation that you're doing, you're going to get pretty good at it, right? You're going to get good at it because truly it's going to become much more autonomous. Now, there's no such thing as 100% automation. It doesn't exist. That just does not exist. But you want to have high reliability systems, much like aerospace systems where you have high reliability. In terms of the planner, it's a mix of what we call our edge devices and our cloud. Now we have, I would say, the world's best cloud system out there. We've been doing it for a long time. We have a tool set. The same tool set that we use inside of our fulfillment operations is available to many, many businesses, and many, many businesses are using that tool set, where it's a safe, secure, authenticated AWS stack that allows us to do generative AI solutions at will at really low cost. So the planner that we have, is you can think of it almost like a flight controller over at Logan, where we can see and we're saying what bots we want to go at what time. And that's all, it's a massively parallel operation, right? And we do that all in the cloud. But that's not good enough. Now, there's latency between the cloud and whatever robot that you have. So the robot needs to be able to understand, is there an object in my way? Right. It needs to understand, do I have a potential collision coming in my way? And that's starting to be embedded into, or is there a person in my way? Is there somebody who's doing servicing? That's all now happening at the edge. So there's this balance that we do inside of robotics of like, how much smarts do I want to put on the edge, and how much do I want to put up in the cloud? And as we progress more and more in robotics, we're seeing that the more unstructured that you go, the more details and smart you're going to have to get on the edge.
Sure.
Right. But when you start to get in the edge, now we're talking about you want lower power embedded computers that can have their own models. Maybe you don't even have the connectivity back that you want. And these are real challenges that we're looking at, and we're starting to solve inside of Amazon. So it's really incredible to see literally 3,000-4,000 of these bots working together with each other, learning from each other, learning where they can be stronger, learning where they can be better, and then you see the system be optimized like right in front of your eyes. It's incredible.
Fascinating. That's amazing. Let's talk for a little bit about how generative AI has changed. I mean, you've alluded to you're using generative AI, and I can really imagine how, the vision models, for example, like you have these vision models that can look at a scene and understand where objects are. But can you talk a little bit about how generative AI has affected other aspects of robotics, like these manipulation questions?
Yeah.
I mean, has generative AI had impact in other areas or planning?
I will say this. Like I said, I know you're all shocked because I said I was programming in the 70s and I look so young, so I get that. But I will say this. I'd say generative AI is probably the most impactful technology that I've witnessed, like throughout my whole robotics career. And I tend to think of it in three bins. I'll just throw this out there. I love being on campus. Again, it's great, so maybe I'll get my academic juices going again here. Please, no problem sets tonight, thanks. I really think of it in three categories. There is, I would say, kind of the collaborative AI, language-based, language in, language out. Help me summarize this document. Write for me prose that compares and contrasts these thoughts. Like that is language in, language out, and that really we all should be using those tools, right? It just makes our jobs easier, and we are, right? Then the next bucket that I put is kind of creative generative AI, and this means that the generative AI solution is giving us designers insight and maybe that we haven't had before, okay? So inside of Amazon, I can give you an example, a very specific example, is that we think about process flows, we think about material flow throughout our buildings, and this kind of creative, we can ask our AWS-based generative AI tool sets to say, hey, could you tell me a better way that material should flow, given all this data that we've given you? Where are the choke points? And what our designers see is they see something and it's never quite right.
Right. It's not going to be perfect,
like,
but it might inspire you. Yeah.
That's not, no way could I ever build that.
Yeah.
But they begin to see, like, oh, I didn't realize that is actually, the main choke point. Or I didn't really realize that we had that much volume at this particular outbound dock or this corner of the building. And that insight gives them a better way to design a solution. Now it's their solution, and then out comes a new next generation fulfillment center.
Yeah.
Okay? Seeing that, actually, again, I think I'm going back to my MIT days. We did, I was here on campus at the Center for Space Research, and we did an algorithm, a genetic algorithm to design an antenna. This is another good bucket for kind of this creative. It had many, many generations of antenna, and it ended up like you could not physically build the antenna. Like we didn't have any processes to actually build that antenna. But it gave our RF engineers like, oh my gosh.
Right.
I see why it's working, and he built this antenna that we put on a spacecraft and off it went, which is awesome. So that's the second bucket. But the third bucket is really where I think there's a great amount of challenge, and I just call it operational Gen AI, okay? And I have examples of this. So that fleet of bots that are out there, for example, we just announced what we call Deep Fleet, and it's a generative AI solution that is continuously running to say, I know what your algorithm is right now that we've used for a decade. I'm going to take that algorithm in, and based on the data that I'm seeing and based on the real-time conditions of the fleet right now, I'm going to optimize that a little bit better. It's going to see the patterns inside it, and it's going to suggest, it's actually going to generate, purely on its own, a better route for one particular drive. And it does that across thousands of drives. And then suddenly, everything is blended together. We really like that. We saw that this past year. We just announced this a few months ago, and we're deploying it across all our fleets. What it does is it gives us a 10% efficiency in drive time. Mm-hmm. And 10% on
a lot of
these
dollars,
buildings are 3 million square feet, right? There's thousands and thousands of drive units is a really big deal. When we put this together, again, I want to just bring this back to what our customer and why this matters. Is you put these systems together. For example, we have our latest generation fulfillment center in Shreveport. It's 2,500 new jobs we put down there. We're seeing that we can process entire orders 25% faster throughout that building. We continue to hire, right? But we're also seeing productivity gains. Right, we're seeing efficiency gains and productivity gains inside that building, and we also see the jobs changing inside that fulfillment center. Right, so again, very practical, very real world, and embedded into the operation itself. Right.
I'm wondering, Ty, if you could talk a little as you're talking. I was sort of thinking about this job question. A lot of things that people are worried about with AI is it's going to replace people.
Yeah.
You're pretty far ahead, it seems to me, you're pretty, this is
I think that we're pioneers in this field.
A high degree of automation, right? You've already deployed an autonomous, these robots pretty extensively.
That's right.
How has your human workforce changed over the years in terms of, I don't know if you can talk about numbers of people employed in these fulfillment centers or the types of jobs that people are doing, or can you talk about that?
Absolutely, I can 100% talk about that because I'm very proud of it. When you give people the right tool set, when you give people a mindset of augmentation and amplification of their job, when you can eliminate the menial, the mundane, and the repetitive out of people's jobs, it frees them up a bit, and it allows them to focus on higher order things, right? So it's a very hard job to do that, by the way, because if it's not really useful and you have a job to do, you're going to put it over here.
Yeah.
right? If it's really useful and you have a job to do, and you're like, okay, I like that. You as a designer really need to pay attention to the signals of what do you like about that and why is this useful to you, all right? So how jobs have changed is that we're seeing, and also I think we all have a responsibility, especially a large tech company like Amazon, to upskill our employees. And we have put more than $1 billion into upskilling more than 700,000 of our employees. We have something called career choice, where right in our fulfillment centers, folks can learn about AI systems, folks can learn about robotics, folks can learn, they can actually take any college course that they want on it, and we really believe in that, right? We also believe that, and we've seen this, where people, when they're using it as amplifiers in augmenting their work, they like it and they want to be more involved in this. So we have what we call a robotics apprenticeship program, very successful, that we've rolled out through our fulfillment centers, where if folks want to get involved with robotics, we will teach them how to service them, how to maintain them, what to look out for example. And we've seen a pretty good increase in the folks that are doing that. Why? Well, first of all, it's 40% more pay, right? It's great pay. Secondly, you're working in the tech field, and it's a great career. So we're seeing that. Like, if you want to pop up one level, my philosophy is that we are pioneers in this field. We are pioneers when it comes to collaborative robotics, when it comes to building machines that allow folks to be more efficient. And I say that because we have a huge advantage. We're in e-commerce. We kind of invented this goods-to-person fulfillment strategy, and we have a semi-structured environment, right? We have more than 300 of our buildings are robotics, like what you saw in the video, robotics-enabled buildings. It's a huge number. And when we try something, we think of something, we convince ourselves that this is going to be good for our employees, it's going to create a safer environment for our employees. We will build it in the lab. Okay, that's what we do. That's cool. But that's only the beginning. You build it in the lab, and then we'll take 1/4 of one building and one floor, and then try it in the real environment, and we'll see how that works. And you iterate. We iterate our AI systems. We iterate the mechanics. We iterate the robotics. We listen to the voice of the customer. And what it does is it allows you suddenly you're uncovering, like, oh, I didn't think of that. Oh, I didn't think of that. Yeah. Oh, I didn't think of that one. Right. And then it gets better. And then we get one floor. Okay, great. And then we roll it out and we're like, okay, it's actually working now. Oh, wow. Yeah. Okay, it's good. And then I usually look for the big clue, which is the general manager of the building will say, oh, no, you guys, you probably shouldn't release that yet. I'm like, why is that? Because they're gaining efficiencies, and compared to their other general managers, I was like, hey, I don't know whatever you guys have, but I want that cup of coffee. That one looks pretty good. So we roll it out more generally.
Awesome. Maybe let's turn to a little bit sort of visionary here. And hearing you talk, you said it's a semi-structured environment, which I take to mean you kind of know the floor plan of these buildings, and you have to watch out for people, and sometimes there's things that aren't where you expect them to be. But it's not like walking around the MIT campus or something. So, but and we've heard about drone delivery or whatever. But I'm wondering, like, looking forward, I mean, how far away are we from the idea that I might have a robot that's like Amazon is delivering my packages with a robot that rolls up to my office or rolls up to my, walks up my front steps and drops my package off? Is that going to happen soon?
I will say that we will innovate in every way for our customers, for sure. I will tell you that we are already involved in the majority of deliveries out there. The robotics, Gen AI, machine learning, we've been doing machine learning from kind of the get-go. If you think about the product placement out there, we're there but never satisfied, right? We want to have the ultimate in customer convenience, which means the world's largest selection of goods at a low cost, delivered right to the customer's door. That's what we do. That's just what we do. That frames everything that we do inside of our robotics and automation. And to do that, you really need to understand the scale at which we operate and the pressure that puts on a robotic system that actually works. It's not a YouTube moment, it's not a backflip, it's not parkour, it is getting goods to customers' door. And that is in itself a remarkable achievement. And when you talk about the vision that we have, like, I genuinely believe this. I really do. This is why I'm so proud of the women and men that work inside of Amazon each and every day on these really cutting edge, whether it's the Gen AI, the new foundation model that we have, whether it's in the hardware stack or the software stack, that what we're doing inside of e-commerce through practical, everyday applied robotics, actually, I believe will start to transcend into other sectors, whether it's agriculture, or it's automotive, or it's in healthcare, like the basics of, I mean the basics, moving stuff, manipulating stuff, identifying stuff, right, sorting stuff, those are the basics. And we're just starting to do that at scale with reality. That now we're gonna go into other sectors, and then we get the holy grail, what like the part that really puts a smile on my face is because then that's gonna start to work its way into every home.
Yeah.
Every home out there, right? Allowing people to focus more on what matters, right? Allowing them to focus on their loved ones in their house, allowing them to do other jobs and have all the menial, mundane stuff done for them.
We've seen Elon Musk, I guess, kind of famously say that bet on humanoid robots and say Tesla is going to be whatever it is, $25 trillion company on the backs of this humanoid robotic bet. Would you bet on humanoid robots, or are you imagining more in the home that these kind of things that we saw in your video are more small scale, human friendly things that move stuff around for me, or like what are your?
It's funny. Again, I'm on campus, so I'm inspired here for sure. First of all, we have millions of robots already out there. So it's not about this is what we're going to do, this is what we are doing, right? And they have very practical purpose. I always start, what problem are you trying to solve? First and foremost, what problem are you trying to solve? And I would say that to everybody, every single person out here. If you're thinking about some technology, you should start with what problem are you trying to solve first. Because if you're just technology, looking for technology's sake and how am I going to apply this, it's not going to work out so well.
Yeah.
So start with what problem I'm trying to solve. From that, I generate function. What functions will I need in order to solve that problem? It's not form, but function. So humanoid is a form. If you start just in the form and say, I think you're starting to fall into this trap of like, okay, how can I apply this? And there's a thought, and I get it, and I understand it, and I appreciate it of like, well, it's going to do everything. It's going to be general. You think of it, and it can do it.
Anything a person can do, it can do better.
Right?
Yeah,
and I don't believe in that philosophy. Like I believe that it's a system of people and machines working together, right? Like we should have the strengths of machines doing repetitive motion, lifting heavy objects, calculating huge numbers for us, understanding where all our inventory is. That's what machines are really good at. And let people have common sense and use their instincts and the ability to problem solve and understand the overall flow and of what happens and bring those together in a smart way. And at this conference, I'm very excited to be here because to bring that intuition and the common sense in a human relatable way is where I think that we need a lot of work, right? I think that we need a lot of work there, not as a combative or a versus, but as a collaborative way so that allowing us to use our machines better.
Cool. I'm wondering, we got a minute and a half left, so maybe I'll give you one.
That was
I know, it went fast, yeah. I'll just ask you one question, like...
is this the good one?
This is a really good one.
Just zing me with something, I'm ready. I'm prepared.
No, I don't think I have a good one. I'm sorry.
All right.
Maybe like just as you think about, there's probably a bunch of MIT students and researchers in the audience. Like, what would be if you could say, like, here are the 3 things that we need in robotics. Like, what would be the big breakthroughs that you would want, or you think are needed before we get to this, whatever it is.
Okay.
Elon Musk's
and do that in 55 seconds.
Yeah,
I'm ready. All right, you ready? I'd say we need. I would say. Much more in human-machine interaction, more research there. In the hardware stack, I really think that we need a breakthrough in low-power embedded, maybe even neuromorphic computing, so that we can carry a little bit more on the edge from the hardware point of view. And also the system point of view, even if it's humanoids or if it's wheels or it's 4 legs or it's 1 leg or 6 or whatever, once you get to a spot, you then need to interact with something. So I really love the work that's being done, particularly on campus here in dexterous manipulation. That's my research. If you gave me grand challenges, They're not going to. They're going to be very practical. Do you see that laundry basket over there? Mm-hmm. You can imagine this laundry basket. I want you to do the laundry and then put it into the drawers.
Yeah.
It's a ginormous challenge if you just think about it. Okay, that would be one. Second, shout out to my MIT homies out here. I want you to, and John Howe, Professor Howe, if he's out there somewhere, we thought of this one together years ago. Just take a robot and carry a couple Amazon packages and go from the end of the infinite corridor all the way out to, Kresge here, when we're changing classes.
Yeah.
That's all I'm asking you
Right.
to do. But just don't hit any people.
Don't hurt anybody
and
on the way,
make your way through that little corridor. I had a hard enough time doing that as a student. That's going to be a really hard job.
Yeah,
that would
that's
be
a great
two.
one. Yeah.
And then the third, I love sports. Red Sox are kind of eating it a little bit, but just play an entertaining game of baseball. Just entertaining.
Awesome.
Just entertaining.
That's really great.
Those would be my 3 grand challenges. So someone bust those out, please connect with me on LinkedIn. I'm out if you have any solution to any of those.
Sounds good. Well, Ty, we're out of time, but thank you so much.
Thank
it
you,
was
Sam.
really a pleasure.
Thank you.
Yeah.
Thank you. Thanks, everybody.